Everyone, Monday night, and you know what this means. It means that class is in session. So,
Mm,
Dr. Albers, how are you?
I'm very well, thank you, Wayne. And how are you?
Doing good, doing good. I'm just, I have to tell you, give me 1 second here. I had myself talking to myself. I know that never happened to you, but it does to me.
Yeah.
So, I'm doing good. I got no complaints. I have had a great week and enjoying things. I'll
Mm-hmm.
just say everyone hello in the room. Brenda Fisher, there you are. Sue G, hello. Roni, Matt Hatter, Claudette, good to see you. Gary Baxter. Well, I'm going to tell you what, Professor, the classroom is filling up.
Oh, wonderful.
Good.
Everyone's very welcome, to the
Well,
class.
I'll tell you what I feel about this, Claudia,
Yes.
is that the great thing about what you bring to us is exactly what you have said all along. Free thinking.
Mm.
Yeah, imagine that. Free thought.
It's amazing that we have this wonderful ability to think, but what really happens in school is often you get blocks from thinking. You were a free thinker as a child, and then you go to school and they teach you how not to think.
Ooh, you know
And
what?
they bore you to tears. They teach you lies. They teach you things that don't make sense. And when they start doing that, you start thinking, but I don't understand. And you think it's you. The problem's in you. The problem's not in you. The problem is they trying to teach you things that really do not make sense. And then they make it complicated so that you start thinking, no, but it's just me. I just don't understand this. It's because I'm stupid, but it's not. It's because they're teaching you lies.
There you go. I have been in classes to where the teacher was one of enthusiasm, encouraged. Dead Poets Society, I think, is the best movie that
Uh-huh.
typifies exactly what you were talking about.
Mm-hmm.
A professor who comes in and, of all things, reads poetry,
Mm.
and it leads to an explosion of free thought, free thinking. And I don't understand the people that attack you. It boggles my imagination. They will come after you because of your thesis, your hypothesis, your theories, your ideas, your
Mm-hmm.
thoughts,
Mm-hmm.
and it's really hello, Brandon. How are you? Good to see everyone in here. That if it was them, they would absolutely be crying foul if someone was doing the exact same thing that they're doing to you and trying to
Mm-hmm.
suppress and your thoughts. And to me, I've challenged a number of them, and I'm very courteous, which they are not. And as I
Mm-hmm.
tell them, if you want to be mature and if you want to have a rational cognitive conversation, let's stop with the personal attacks, because the minute you start going to personal attacks, you've already broadcasted to everyone in this community where your conscious level is at.
Mm.
And here, Claudia, you will always be welcome.
Thank
We
you.
will, in fact, ensure that you have a platform to bring to us what has been nothing but week after week of stimulating thought. So
Mm.
there you go.
That's
I
why.
just want to say
Thank
thank
you,
you.
Wayne.
So, getting
Mm.
on with the program, I thought
Mm-hmm.
I would bring something to us that you might like to see.
Okay.
So, give me a chance. I
Mm-hmm.
have this. I'm going to get it fired up. So I'm doing this little expose just to let you know
Mm-hmm.
on Sechi.
Oh.
And it's called 10 Years of what I call disclosure to tyranny. And what I mean by
Mm-hmm.
the tyranny is the fact that they have taken this off and I think it's one of those things that when we look back, we go, what was going on here? So I pulled this up, and now that I have it up, I can show you. Do you see that?
Oh, yes, yes,
Okay.
I see that.
So this is, ladies and gentlemen, this is February 19th, 2007. And Claudia, this
My goodness.
is stereo B that no longer is working.
Yes.
And I just thought I'd play this for you, Claudia,
This
because
is unbelievable.
watch this. Is this just the most amazing piece of footage? Now, what I found was so we could look at this, and I've got other stuff to show. So
That's obviously the sun interacting with a very large object.
one, I would agree with you on that.
Extremely large object.
Now, how about this one? So you and I have talked about this at length, particularly when you and I were first conversing when no one really was aware.
Yeah.
So how about this one? We got this one now in the X-ray particles. Watch this. Is this just amazing?
Oh my goodness. This is actually not even a single object. This is several of them together. And the sun's interacting with them.
Look at this.
My goodness. This is huge. And
look at it rotate.
yes, it is rotating.
So now what some people have tried to say, well, this was just they were adjusting the camera.
They were adjusting which part of the camera?
I don't know. They never
because this is not in the camera. This is what the camera is looking at.
And particularly when we look at it in this spectrum.
Exactly.
I thought you might find that amusing. So
that was a SRAM image. Is that so?
Yes, that is correct.
So that's ionized particles. It's high energy particles it's detecting. It doesn't even have a lens in it. It just detects particles. There's no way you can have lens effects without a lens.
Now you're going to get technical on us, aren't you?
Cannot help it. Sorry.
I know it. So this weekend, I've had a very odd phenomenon here. I wanted to show you these pictures. So I got these pulled up because they were doing a lot of chemtrailing here. So this was Saturday, and I'm going to show you.
Yes.
You can see, and then this appeared. Now, this is a very odd.
It is.
Very odd, because look what happens as I do the time lapse on this. I actually come in here, and what's really odd, Claudia, this chemtrail is on top of this.
Yeah, you see, that's a wave pattern. That yes. You can see it has a wavelength. It repeats itself.
Yes.
That's a wave pattern. You must have some kind of wave oscillating electromagnetic wave in order to produce this type of pattern in the clouds.
That's what caught my eye immediately. I'm going to go back because I want to go back to what really, when you look at this, it is just the most bizarre thing because what caught my eye on this, Claudia, was the fact that this chemtrail is above whatever this is. Now, I live right next to the mountains. I live at 6,000 feet of elevation. These,
that's high.
It is, yeah. I've gotten used to it. This type of cloud, you can see that it is so out of place that it doesn't even belong here. There you go. There is what I saw. Now, what caught my eye secondary to this when I was doing some analysis, Claudia, look at this square object here.
Oh my goodness.
Exactly. I said, oh my God. What? Look at this. It's
Look,
huge.
it has to be an artificially produced thing. I mean, you do not get straight lines in nature. That's what I like to say. So this has to be artificially produced. But I do know that they are producing artificial designs in the sky because they have covered the whole of our atmosphere with it seems to be a lens system, because the sun simulator is actually very small. Now and then you can see how small it is, sometimes within clouds.
Mm-hmm.
And then the lens system, it's almost like something they spray. It's like in the atmosphere, like a layer in the atmosphere that works like a lens system. And it works on the sun simulation system so that it makes it go in the right angle that they want, so that the sun seems to be in the right place. It also magnifies that simulator so it looks a lot larger, like something like 8 times larger than it actually is.
Okay. That would make sense.
It's a magnification system for the sun simulator. And it seems to be some kind of layer they've put in the sky. So I'm not surprised they have these square patterns. Our sky is almost completely artificial now. There's hardly anything natural in it anymore.
I agree with you on that. And I happen to think, and there's others that agree with you on that as well. Now, I have a friend who, I won't say where they work, but they said that, like you said, this is a wave pattern. This is being generated by, and it's odd that you said this because I wasn't going to say anything, an electromagnetic field is the only thing that could be generating with the consistency. And it stayed up there for a while. I have to say, I was, you begin to notice. Now, this was later in the day, same sun. And you can see that this is now, these are all chemtrailing. It's nothing up there that you can see. But what I found interesting, again, Claudia, is how we're getting these obfuscations of light in the sky that I don't understand how clouds do this type of blocking.
Yeah, these are not normal clouds. This is this haze which they spray in the sky so that we don't actually see what's behind it. And yeah.
Okay.
Oh my goodness, what is that?
Yeah, so hold on to your hats, folks, because this is what showed up yesterday in my skies. There it is.
Oh my goodness. That does not even look like chemtrails. It looks like a
weird
pencil drawing in the sky.
Yeah, I don't know.
Of a planet?
I see. Yeah. I don't know. Maybe someone is messing with us. So there it is. It stays up in the red shift.
Yes.
Here it is in the green shift.
And it has a slight circular shape to it, which it could be associated with an actual body there, an actual celestial object. It's possible.
So I just thought I would share a couple of those with you.
Very interesting.
Yeah,
interesting.
We live in interesting times, don't we?
Yes, we do.
Yeah.
And to me, the most interesting thing is what I am understanding about the universe. And this all came about through studying these stellar cores that are affecting our sun and that are found are affecting the Earth. And through observation of what these things are doing and trying to understand them, I started to understand what the universe is really like. And it's totally different from what we've been taught. You've read some of my papers. You know that the most surprising thing for me is that everything comes out of light. But why should it be surprising? Because it agrees with what the Bible says, that God said first, let there be light.
Indeed. Absolutely.
So everything comes out of light. But it's amazing.
So I'm going to pull up an article that you and I, because we're going to talk about the paper you wrote on this, and I thought that maybe we could share exactly what you were talking about. So this article was sent in, and I forwarded it to you.
Yes.
Let's talk about this. So what's going on here?
Well, this is based on a very old theory from 1934.
1934?
1934, yes. This is when QED, which is quantum electrodynamics, came into being, which is the understanding of electromagnetism through quantum mechanics. Or actually, it's the absorption of electromagnetism into quantum mechanics. And then they discovered then that what happens is light, a gamma ray, for a small amount of time will create a particle-antiparticle pair, and then they will annihilate again. This is all inbuilt into quantum mechanics, the creation and annihilation operators, with which you can describe position and momentum.
Okay.
And out of it, so they discovered, well, light can become a particle-antiparticle pair, and a particle-antiparticle pair can become light again. So this was all part of, so they said, now, well, we can create matter out of particles, and it may be possible that if we smash two photons together, then we will see this particle-antiparticle creation. Now, these particle-antiparticles have been seen in other ways, in accelerators. Whenever there are particle collisions, you often get gamma rays coming out, and these gamma rays then turn into particle-antiparticle pairs. And this is seen in the chambers where they can track the particles. So this is known to happen already. But now what they want to do is not through particle collisions, which is done in accelerators. They want to actually smash two photons together and see the particle-antiparticle coming out of it. Which to me is, because what I've discovered is that a photon turns into a particle, I call it two particles of opposite charge, when it moves through an electric field. So smashing the two photons together, and they're going to use lasers, they're going to use high-powered lasers, is the brute force method. They like using the brute force method all the time, smashing particles together. And in order to get to outer space, you use a lot of fuel to overcome gravity, when all of this is not necessary when you really understand how things work. So moving photons through a region of high electric field will cause it to turn into particles anyway, but they don't know that because they haven't read my articles.
And we're going to pull one of those articles up. Well, in fact, when I was reading your article this evening, and I'm not finished with it all, but so as I understand, it's really coming in here and taking a photon and actually seeing that now become mass.
Yes.
So I extrapolate into my thought process that when I'm hearing that is God said, let there be light, and there was light. And then the next thing we know, we start having mass being produced in the form of a planet, and et cetera, et cetera.
Mm-hmm.
That the building block, which you could say would be the universe's DNA, would be actually the photon.
That's right.
Photon. Okay, see, guys, I know how to read, man.
Photons turn into particles under certain conditions. So particles with mass are actually photons in disguise, so to speak.
Okay.
It's just that they're not moving at the speed of light anymore, and they have mass now, and they have opposite charge so that they can interact electrically with each other. And the most recent article which I wrote today, I go into actually energy, where I show that all energy is photons. Energy is not an abstract concept at all. It is a particle. It's a photon as well. I sent you that one already, but you haven't had time to.
The 180, is that 189?
No, that will be 191.
Okay, yeah. This one I'm still regurgitating
but
on.
that's fine. This one is where I show that all matter comes from light. And as you see, I did start with that article that you sent me. I read it first, so I introduced the whole thing with that article. But this is where my understanding started with gravity itself, and how gravity is an interaction that causes the proton and the electron, which is oppositely charged, to separate, to repel each other, to move apart. And this seems to be why when a photon, which is a light particle, moves through a strong enough electric field, the two particles split from the photon and move apart in opposite directions.
This is the one that the reason why I highlighted that, Claudia, because I wanted to see if you could talk a little bit more on this one. So, because and I don't have the math to back that up, which you have that discipline. So what I am seeing is that I'm seeing a photon begin to hit into an electric field. All right. So an electric field is that we have all these electrons now that are excited, right? And they're generating. Yeah. Go ahead.
An electric field is what you get when you have particles of opposite charge separated.
Okay.
They are a distance apart, because the electric field then is in the region between the two particles, and it's outwards from the positive particle, and the proton is the positive particle, and inwards towards the negative particle. So the moment you separate the two particles, the charges, you get an electric field between that.
Is that a reaction or a byproduct of the result? This
is a byproduct of the fact that the two charges have a characteristic called charge. So, just like particles have mass, they also have charge.
Okay.
The charge causes them to interact electrically. And when they interact electrically, it generates a field in the region around them. And that field is called the electrical field.
And so the photon can actually pass through the electrical field basically unabated, that it's unimpeded in the interaction with the electrical field?
Yeah, you see, the photon should not be affected by the electric field because the photon has no charge and it has no mass. So it shouldn't be affected by a gravitational field or an electric field. But because it has particles in it, this is the way I saw it.
Okay.
The particles sense the electric field, and the proton, because it's positively charged, tends to move in the same direction as the electric field, whilst the electron tends to move in. It's like the electric field actually pulls them apart from within the photon.
I got excited about here because this one I really... I saw this one, that the photon carries the gravitational energy with it. That's right. Interesting.
Yeah, because I realized that in order to explain the structure that we see in the universe, we have to have that the gravitational field is not just attractive. It has to cause particles of opposite charge to separate from each other, which is repel, move away from each other. And if there was no gravitational interaction, then the whole universe would collapse into neutrons. And I'm about to write another article which will show that neutron stars are the ultimate dead star. This is the end of stars. When they've lost all their energy, then the gravitational interaction is not strong enough to keep the proton and the electron apart, and they collapse into neutrons. And then they dead. They cannot produce light. They have very low effective, they're not strong and very attractive to other matter. They're actually very weak. They have very low effective mass.
I was
and
going
they
to say,
cannot
so what kind
emit
of
any
mass
light.
is the mass collapsing within itself as well?
Yes, because the gravitational interaction, part of it, not all of it, actually all of it is due to the energy carried by the photon. The particles themselves have mass, which comes from the energy of the photon. But then there's still extra energy, which comes from the rest of the photon, and that energy strengthens the gravitational field. So the more energy the photon was able to give to these particles, the more the proton and the electron will repel each other, and the more will two protons attract. And the fact that two protons attract, that's what we see as this pulling energy that planets feel towards stars or towards each other. That's the attractive gravitational force that keeps planetary systems together, that keeps galaxies together.
There's a certain cohesion, right?
That's right. And it's the same as the strong force which keeps nuclei together. It's exactly the same force. There are only actually two interactions in the universe, the electric and the gravitational.
Can we stop? Go ahead. I'm sorry.
All forces are due to those two interactions, which in a way oppose each other. But they are also interrelated. That's why I call this unification. It's unified field theory. It's what Einstein looked for at the end of his life and could not find. Because the electric and the gravitational have to work together. It's like an action against each other constantly, one against the other. And that's what builds the whole of the universe. It's these two interactions. But they come from within the photon because the particles come within the photon, and everything is built out of energy that comes from that photon.
So what I'm seeing here is that when I was growing up, the atom was the big discovery, the thing that was changing, revolutionizing our science and our perception of the universe. What I'm seeing here is that, well, wait a minute. Yes, the atom has a definite role here, but folks, it's really the proton. It's the photon that's out there that is actually causing all of this to happen to begin with.
That's right. Everything starts with the photon. All energy, all matter, all comes from the photon. The interactions themselves, because the interactions are with the particle. It's like having two human beings. How do they interact? Okay. They may talk to each other. They may hug each other. Two types of interactions between two people. This is what we have with particles. The particles are created. I call it a creation event where a photon turns into two particles.
Okay.
And now they interact with each other. They have two ways of interacting. It's the electrostatic and the gravitational.
Which, by the way, when I read this afternoon, you see, the one thing as you and I have discussed in previous shows is that the understanding that gravity is a constant, that it doesn't matter where your position is, gravity stays a constant. Okay. I could never see, well, then how does it become a constant? What's the force driving this? But if I look at it at a particle basis down at the photon level, that what you're teaching me here is that I have a symbiotic relationship between the electrostatic interaction with the gravitational. Mm-hmm. And thus gravity would then be unified no matter where you apply it at.
That's right. You always have the two together because the gravitational separates charges. And because charges interact through the electrostatic, the moment they are separated, it generates an electric field. So the fact that they are forced apart and yet they still it causes or it creates the electric field. So the gravitational interaction leads to the creation of electric fields. And the electric fields actually cause other photons to turn into particles. So you get this feedback loop constantly.
But light can be both a particle and a wave, right?
Yes. Well, photons are
photon.
both particles and waves. But in quantum mechanics, we describe everything, including particles with mass, as waves or with a wave function. But they would be contained through a certain region of space, whilst photons are seen as free particles. The wave function occupies the whole of space. So they're unconfined, basically. But even quantum mechanics needs to be revised because it's not understood that all particles are actually photons. And the interactions are not separate from particles. The interactions are within the particles themselves. The particles interact because the interaction is inbuilt within the particles.
Okay. So if the photon has a higher rate of inertia speed, and I'm trying to see this, would that cause a intensity in a gravitational field?
Yeah. What happens is the photon, when it moves through a region of electric field, it doesn't always split. That diagram there, let's look at it a bit, Wayne.
Which one? This one?
This one. Okay. I think it's the one above that.
This one right here.
You see what I have there is a photon which contains the two particles in it, but they're in dashed lines because they haven't manifested. They are within the photon. And when it moves through a region of high enough electric field, then it turns into the two particles. And the photon, then whatever's left of the photon splits into two halves. And then, so you end up with two photons within the proton and the electron, but they have lesser energy than the original photon. So now what you have is particles with photons in them. So you start with a photon with particles in it, and you end with particles with photons in them. And that's the energy that the particles have. They have energy as mass, and they have energy as a photon.
Okay. All right.
So
now, is the variation in the gravitational repulsion, is that a constant, or is that going to be more of a dynamic variable depending on what we have here?
So what we have is these particles have a certain mass. That doesn't change. If the photon has enough energy, it can turn into two particles of a certain mass. But then on top of that mass, and mass is also energy. So the photon, some of the energy of the photon turn into these particles with a certain mass. So that's some of the energy of the photon. The rest of the energy of the photon stays with the particles as energy, which again is smaller photons basically. But that gives you the strength of the interaction. So what we have is when we have a nucleus, and we have there on the right-hand side, it's basically a lithium nucleus.
Okay.
It has 3 protons and 1 neutron in it. And then it has electrons on the outside. Now, the electrons on the outside, because they are repelled by the protons, the red ones in the middle, they cannot go into the nucleus because the gravitational interaction pushes them outwards. So they'll move outwards until the gravitational interaction is not that strong anymore. And then they pulled in towards the nucleus by the electrostatic, because according to the electrostatic, the protons and the electrons attract. That's the orange arrow. That's represented by the orange arrow. So then what happens is the electron goes into orbit around the nucleus because it's pulled in by the electrostatic. But it cannot get any closer because the gravitational always keeps pushing it out. But then the electron absorbs a photon, so it absorbs energy. And when it absorbs energy, the gravitational interaction gets stronger. So now the electron is repelled more strongly by the protons in the middle. And that causes the electron to move outwards some more. It moves to a higher energy level, or it leaves the atom entirely.
Wow.
This is how atoms emit light. This is why, because they absorb energy.
Because that's what we're seeing here is light.
Yeah, they absorb energy and they can emit energy when they move down in order for an electron to move downwards to a lower energy level, they have to release energy in the form of a photon. We pick up that photon as light. So if that's a visible light photon, we would see visible light being emitted by this atom.
You know what I was seeing when you were talking on this? I'm seeing the universe. I'm seeing stellar hatcheries. I'm seeing how we see the solar system, the universe itself function, and it's beautiful.
It is. You're right. It is beautiful.
There is such symmetry, such grace.
Mm-hmm.
I mean, that's how I see it.
Yes, it is. It is beautiful. I think God created a beautiful universe.
Yeah.
And it's all built out of what he is like, because the Bible tells us that God is light and there is no darkness in him at all. And the universe shows us that everything's built out of light.
It's quite interesting when we start getting into this theory that, and here you actually get into the math. So
yeah, I actually explain it in terms of equations, as I understand. And Einstein, he said he's got this equation, E equals mc squared. Basically, he was saying that mass is equivalent to energy. And basically,
so energy is equal here. So energy is what, a photon?
Yeah, basically a photon is energy itself.
Okay, all right.
Here I explain it in terms of gravitational energy. In the next article, which you will get to read next, I actually show its heat as well. And because it's heat, it's all forms of energy. Whenever energy is transferred from one particle to another, that's what's transferred between particles, a photon.
Interesting.
So in here, what I say is, so the energy of the photon is equal to the energy associated with the proton, that's the first E of P, plus the energy associated with the electron. And the energy of the proton, then, yes, what's in the brackets there is the energy associated with the mass of the proton, that's EMP, plus the energy associated with the gravitational energy of the proton.
Excellent. Okay.
And then the same thing with the electron. The energy associated with its mass plus the energy associated with its gravitational energy, which gives you a part of the strength of the gravitational interaction it will be able to have.
Wow.
Yeah.
Holy crap. Excuse me. This is cool.
Yeah. And that gravitational energy that each of them is actually exactly the same. It splits in half. It has to split in half in order for us to get the structure that we see. One cannot get more than the other, because if it's not strong enough, then they will attract each other under the electrostatic interaction, become neutrons. And we see this happen. This is why we have neutrons within atoms. Sometimes the photon doesn't have enough energy and they come together and become neutrons. So it has, that part has to be symmetric, even though the mass of the particles is not.
You know, this is going to help me so much, Claudia, as I begin, you know, doing just from a layman studying these equations. I can begin to see, as particularly like you said, we have here in LASCO, when we begin to see the interaction now with our star, understanding what really the interaction is taking place here. This is going to be different because I know so many astrophysicists, so many physicists themselves don't look at the photon as the primer of the universe.
You see, the way we are taught at university, we are taught to focus on matter, on particles. We are taught that energy is an abstract concept, an accounting. This is what we are taught in ways that teaches us to see the universe in a way so that it blocks us from seeing the truth. Basically, it's like a brainwashing that you have to unlearn it almost in order to realize what the universe is really like. Yeah. This is why I say, because I absorbed everything I was taught as a student. It was only when I started teaching that I thought, but wait a minute. So I needed to really understand so I could teach it properly. But this doesn't make any sense. It does. Yeah. I cannot logically comprehend how this is connected to that. That's how I started thinking there's something not right here. And as you can see the connection that these objects make. Yep. And I realized that it's actually a gravitational connection, although you can think of it as magnetic because these particles have charges. I used to describe that in terms of the magnetic, but even seeing it as a magnetic connection blocks you from seeing the truth of what the universe is like. You have to realize that connection, there is a vortex. And whenever you have this vortex, you have a gravitational interaction. This is why light, why water, when it's attracted towards the center of the earth through a hole, it creates a vortex.
Interesting. So it's
also always associated with the gravitational interaction. And this shows that what these particles are doing is a gravitational connection with the sun. They're actually pulling particles from the sun, and the particles are spiraling towards it, forming a vortex.
Claudia, so so often when I see light, I see it as a constant, that it basically covers everything, you know, and that's how you see this. But what I'm looking at here, which tells me that it's possible. So could we actually see, and I don't want to use gravity wells, but could we see these type of vortices with light?
I'm not sure about light.
Could photons
form a vortex?
Yes.
I don't know, to tell you the truth.
Could you look into
Probably
that?
Not.
Probably okay.
Not. It's probably only the particles themselves that can do that, because particles interact gravitationally, and even the magnetic field, the electric and the magnetic field will cause particles to spiral as well. So it's not surprising that the gravitational field does it too. Yeah. But I think the photon, not necessarily. Although I've come across, I'm going to write an article about it, that superfluids, helium becomes a superfluid when it gets to a very low temperature. And from what I've learned now about energy, it would have very low gravitational energy. So what's holding the particles together is not so much gravity anymore, but more electrostatic. And a superfluid has vortices in it. If you shoot it through the air and it spirals, the fluid itself is full of vortices inside it that actually keeps the fluid together. I have to think about it.
Vortices within vortices, huh?
Vortices within vortices,
Wow.
actually vortices within a tiny, a micro droplet of fluid.
Wow. So that's what was getting me to thought that if a particle, because you taught me this, and I'm just trying to figure this out, that if I have a heavy particle, right? The question that I'm trying to answer, as it's pulled, would there be a photon attached to it anyway because of the mass?
There are photons within the particles.
Within the particle. Okay.
But now the particles are moving at a speed less than the speed of light, so the photons are moving inside the particles at that same speed. Now, what causes vortices is, it's usually explained as in terms of a gravitational field within a body that is spinning. And when the body is spinning, it changes the direction of the attraction force to be sideways. And when it's sideways, it causes the particles to spiral.
As I'm looking at this, there is a theory that in the helix universe that actually what we're traveling in the solar system is actually traveling in a spherical vortex as it moves through the universe.
Well, we can see that particles tend to spiral, but this is also because everything is rotating. And I did explain in one of my previous articles how this rotation starts. The gravitational field leads to every particle rotating, because the moment you have two particles attracting each other and they're moving at slightly different speeds, the one moving at higher speed will tend to rotate around the one moving at a lesser speed. So from the moment that two particles connect because they are attracted to each other, the whole system starts rotating.
Wow.
So everything rotates.
I love your work. Well, I'm going to collapse this. I haven't even seen what's in the chat room. Good gracious, they stayed.
Wonderful.
They actually stayed. Well, I'm so proud of everyone in here. I don't know about you guys, but I am learning, Claudia. I am learning to be. I had a meeting today, which I had to deal with a number of people. And in the idle chit chat, someone says, well, what are you doing? And I said, well, I'm getting ready for the show tonight. And they said, what? And I said, well, I have a particle physicist and I who do a show every Monday night.
Mm-hmm.
And they said, a physicist?
Uh-huh.
How can you have a conversation with a physicist? I said, well, it's very easy, actually. and so I start sharing what you have taught me. And these guys are like, now I'm dealing with one that's a pilot. And he's going, okay, a physicist.
That's wonderful.
It's because of you. And I just want to say thank you. You're teaching me. And you see, this is the thing that the trolls can't come against you on. You are teaching us, and you have a classroom of nearly 250 students here that are learning.
That's wonderful. I'm so happy. I love teaching. I just love imparting knowledge to people. I just love to see the look in people's eyes when they suddenly understand something. Oh, I understand that now. It's so enlightening to see it. And I love to help people understand the universe we live in.
Yes, and you do. You are a teacher. That's all I can say.
Mm-hmm.
So I thought I'd just bring this up for you. I thought this one was really interesting because so often you take such brutality. And look at this one. An alien star sideswipes our solar system and sent comets reeling, scientists say. Claudia, what I wanted to do primarily about this was, and by the way, this goes with this book. Everyone in there, I told Claudia about this book. This book, by the way, is a book based upon the theory that Saturn is a star. It came into our solar system, Claudia.
Mm-hmm.
What do you think on that?
I've read about that, and I think it's very possible that Saturn did come. Well, we have a whole system of very old stars that have come into our solar system now. So in a way, this is a soft disclosure of that. We have a whole system of very old stars in the solar system. They're wreaking havoc with our solar system. And so a star came by. Well, they say not that close. It's very, very soft disclosure.
Yeah.
So if one came close, isn't it possible that one can come right into it?
Stellar cores. This is what I thought when I saw this.
Exactly.
Yeah. I mean, I used to see this through lenses that was taught to me by what it was taught in by the current theory. But now when I see this and I'm thinking, well, Dr. Albers' theory of a stellar core makes perfect sense in this scenario that's in this here book here.
Yeah, but I think that that's a very strong possibility. We've had things happen in our solar system that changed it. So it's very possible, and I've heard about this, that the Earth was actually part of the Saturn system, and it somehow got grabbed by the sun, and then it became part of the sun. And Saturn is certainly a star. It produces a lot of light, a lot of heat that it cannot be reflecting from the sun. And it's a strong emitter of radiation, and
Yes.
It has rings like stars are supposed to have, according to the theory, which I first learned from James McKinney, which is that stars actually emit particles and in the form of positive ions, and then they form these nebular rings. The sun has several. The sun is a huge star, so it forms these, which are very far away. They go out to the orbit of Pluto. Well, Saturn forms these rings as well. That's the rings of Saturn that we see. So it has all the characteristics of a star. It is a star. And it's more likely also having fusion reactions within its atmosphere. It's hot. It's got a very hot atmosphere. But what I learned as well is that there is not such a big difference between planets and stars.
Yes.
The main difference between planets and stars is size. When an object forms, it forms out of photons turning into matter, which then they start attracting and therefore condensing into a large object. The larger objects have more energy within them and are able to separate charges more, produce a stronger electric field, and are therefore able to emit more heat and more light than the smaller ones. The smaller ones turn into planets, but they still have an internal energy source. The Earth has an internal energy source, and it's fission. It has atoms or nuclei that are heavy and are splitting apart, fissioning into smaller ones. That's called radioactive decay, and it releases energy. It releases photons. That's why the Earth is hot on the inside.
By the way, I know our hour is come and gone, but that's another discussion I like to get into, because I read an article today about the scientists are becoming more and more concerned that the increased amount of cosmic radiation that is now permeating the mantle, that it is having this effect, heating us up. But I just want to say real quick, so what Claudia was talking about, there are a number of great videos out there that symbols of an alien sky. I would highly recommend you folks go over. It's on the Thunderbolt Project's YouTube channel. Watch it. Because Claudia, what they contend is that they've altered history. Our ancestors, yes, that they talked about Saturn as what they called the gentle sun in the nighttime sky. I mean, it was closer at one time to Earth.
Yes, it was closer. That's why I agree that it's a strong possibility that the Earth was part of the Saturn system. It was one of its satellites. And the sun grabbed the Earth and then it started orbiting the sun. So I think that's a very strong possibility that Saturn was actually a captured star by the sun.
Yeah.
And all the stellar cores are now captured stars by the sun. They came into the sun, and I don't see how they will ever leave, because once captured,
it's kind of like the birth process. There's only one way in and one way out.
Yes.
And many would say that, we could really get onto the esoterical on this, that spiritually, it also has a lot to do that the fact that we were captured by the sun, that this is not the normal light that we should have been in. And I think there's some strong foundation.
Mm-hmm.
Well, yeah. Professor, another hour has come and gone.
Wow, it goes by so quickly.
It does. And I'm just looking in here, and I just want to say thank you all from in here. I mean, there's just, Claudia, people really are drawn to the knowledge that you possess.
That's wonderful. I'm grateful that people are interested in listening to my theories and my explanations.
Yeah.
And my own growing understanding of the universe.
And you know what? I'm learning as you are learning. Mm-hmm. And that's what I think is the great thing about our species, is how we can pass and share knowledge on.
Yes.
Yeah.
Wonderful.
Well, all I have to say is high five to Claudia.
Thank you.
Well, ladies and gentlemen, it has been another amazing Monday night. Thank you all. Thank you to all the moderators, Claudette, Brenda, Gary. Thank you all, Suji. Folks, we appreciate you. Quite frankly, we do it. It was just Claudia and I, but then I would be soaking all this knowledge up for myself. And that's not right. Yeah. Sharing, is it? All right, folks, have yourself a great week. Friday night, we're going to have Claudia, Dr. Richard Allen Miller, another physicist, on, and he's a very entertaining individual. He is a free thinker as well.
Mm-hmm.
So you might want to tune in on that and let me know. I think it would probably be fun.
Sounds very interesting.
Yeah, I think maybe having the two of you on for a show would be awesome. I mean, awesome. That's all I got to say.
Okay.
All right. Other than that, folks, just have yourself a great week. Well, I'm sure I'll see you during the week, and be kind to yourself. Claudia, thank you.
Thank you.
All right, folks, we'll see y'all real soon. All right. Be real good.